Hi everyone. Today we're going to look at analyzing vertical asymptotes of rational functions. So in the last lesson we talked about how we can tell whether a function has zeros, vertical asymptotes, or removable discontinuities, holes, right? Point discontinuities. So we're going to look a little bit more closely at vertical asymptotes and ask ourselves, what is going on? What's happening to the function on either side of that vertical asymptote, right? To the left and to the right of it. So real quickly, just as a sort of a review, all right, let's factor this thing. All right, so we have x, what is this, 24, so it's going to be 8 and 3, no, 6 and 4, right? So it looks like it's going to be x plus 6, x minus 4, over, and then this is a perfect square trinomial, so it's just going to be x plus 5 and x plus 5. Okay? So we can clearly see here that nothing cancels out, top and bottom, so there's no removable discontinuities. We see that there are two zeros sitting at negative 6 and positive 4. And then we're going to have a vertical asymptote at negative 5. Okay? So the question is, okay, now what's going on to either side of negative 5? So the first thing we're going to do is we're going to actually graph this thing and take a look. Maybe a visually, we'll see what's happening to the left and to the right of x equals negative 5. All right, so let's go to our calculator. Okay, let's erase everything we have and put this function in. Again, remember, you have to put the numerator in parentheses and the denominator in parentheses. Okay, if you have to write everything on one line. In my case, you don't have to do that. Again, I know it's a pain to remember always parentheses, right? So you need like double parentheses when you begin. So x plus 6, and then x minus 4. Again, you need a pair of parentheses outside this whole thing if you need to write it all on one line. Okay, over x plus 5, right? X plus 5 times x plus 5. Okay, so my function is in. Just going to make sure I'm on standard window settings. Shift V window, standard. Okay, and then let's graph it. Okay, so take a look here, folks. All right, and I'm just going to zoom down a little bit, or just going to scroll down a little. You can clearly see that at x equals, what is it, negative 5? Negative 5 is 1, 2, 3, 4, 5. You can see at x equals negative 5, something's going on here, right? Take a look. All right, just to kind of exemplify it, I'm going to try to zoom out, shift, zoom out. And then let's put it right here. Let's put the center of our zoom right around here. Okay, there we go. And let's take a look. You see that, guys? You see this? So definitely you can see that, and I'm actually going to graph x equals negative 5. All right, so I'm going to go back. And for this one, I'm going to change the type, F3, and I'm going to change it to x equals. And now I can graph x equals negative 5. So on number 2, I'm going to graph negative 5. Don't use the minus, use negative. It's going to give you a syntax error. And take a look, guys. You see? So at x equals negative 5, I can definitely see this imaginary line where this function is just going to keep continuing downward and never touch. That function's never going to get connected again. It's going to go down like this forever and ever and ever. They're both sides of this function are going to get closer and closer to x equals 5, but they're never going to meet. All right, so let me zoom this a little bit so you can see it a little better. Shift, zoom in. All right, folks, do you see that? So both sides of the function are they're just gonna keep going down, decreasing forever. However, And they're going to keep getting closer and closer to x equals negative 5, but they are never going to reach it. So they are forever separated by x equals negative 5. Okay, so the question is this. Just by looking at this, we can see that as x approaches, right, on the left side of x equals negative 5, this thing just keeps going down. And on the right side of x equals negative 5, again, the function keeps decreasing to negative infinity, both sides, right? So if you look at our choices, the graph of h approaches negative infinity from the left and from the right. So I think that is the correct answer, right? And it is. Okay. Let's take a look at this one. So again, let's work this out. Okay, again, factor it out. So we have x, we have a common factor, and x minus 1 over x plus 1. So again, clearly we can see that we are going to have a vertical asymptote at x equals negative 1. Okay? At x equals 1, we're going to have that imaginary vertical line where the function never touches or crosses. So again, the question is what's happening? What's happening on either side? So again, we can look at it now using the calculator. And I'm going to show you how to do it algebraically too. But first, we're just going to look at the calculator for now. So let's erase this. And we're going to put in negative 1 now instead of negative 5. And then we're going to go up and put our correct function. So again, we're going to have x times, oops. All right, it's x, so we better set this back to y. Let's get out and change our type to y equals. There we go. And then let's put in our function for y equals. So it's going to be x times x minus 1, close it up, over x plus 1. X plus 1. Okay, so again, we have our correct function. Y is equal to x times x minus 1 over x plus 1. And then the x is equal to negative 1. Again, you could have written this as x squared minus x, but I just wrote it in factored form. Now let's take a look at what this looks like. Again, shift, viewing window, we'll make it standard. Viewing window for now, enter. And let's see. Do you see that, guys? Do you see what's going on here? So this function looks like at x equals negative 1, this function from the left side tries to come up, and then it turns around and just drops, goes back down. On the right side of x equals negative 1, this function looks like it's coming down and then it just shoots up again. We have this gap at x equals negative 1 where the function just kind of never meets. They just kind of do a turn and then go. Right? So we call this an infinite gap or an infinite discontinuity at x equals negative 1. All right? So again, from the left side of x equals negative 1, it looks like the function g is going to negative infinity. And on the right side of x equals negative 1, it looks like the function makes a turn and goes up to positive infinity. So on the left side, negative infinity. On the right side, positive infinity. Okay? So let's see which choice gives us that. The graph of g approaches negative infinity from the left and from the right. That means that both sides will be going down. That's not true. How about choice B? The graph of g approaches negative infinity from the left and positive infinity from the right. That is what we said, right? So negative infinity on the left side of negative 1 and positive infinity on the right side of negative 1. So I think that is our answer choice. And sure enough, it is. All right, let's do maybe one or two more. Okay, again, we have our functions here, and we can clearly see that this bottom here, we can clearly see this bottom. If you factor out the bottom, again, you can do the top too. It's going to be x minus, 5, and x plus 1. And on the bottom, it's going to be, that's a perfect square trinomial, so it's x minus 9 times x minus 9, right? Or x minus 9 squared. And that's where we're getting this vertical asymptote, right? If you set this equal to 0, you get x equals 9, and there's our vertical asymptote. So the question is, what's happening to the left and to the right of x equals 9? All right? So what we're going to do is this. We're going to graph it, and then I'm going to show you how to do it algebraically. Let's graph this thing. And we're going to change this. We're going to change this into 9. Okay? And then we're going to change the function into what is it? X minus 5, x minus 5, parentheses, open parentheses, x plus 1, x plus 1, close parentheses, all over x minus 9 squared, right? X minus 9, and we should have put parentheses, which we didn't. Parentheses, and parentheses. I'll just put square, just to save time. All right, enter, and let's graph it. Okay, so we don't know what's going on. We can't see it on this side, so let's just kind of move it this way. And as you can see, clearly it looks like both sides are going to positive infinity. So in terms of the answer, it says the graph of Q approaches not negative infinity, but it's going to reach positive infinity. The graph of Q approaches positive infinity because both sides of x equals 9, you can see are clearly going up. So D is going to be our answer, right? The graph of Q approaches positive infinity from the left and from the right of the asymptote. Okay, but how would we figure this out algebraically? So the way we can do that is this. From negative 9, okay? Now let's see here. On the top, we see that we have zeros here, correct? We have a 0 at x equals 5 and x equals negative 1. We have zeros. And we don't have any removable discontinuities because there's nothing to cancel out. So what we can do is we can kind of do a little analysis like this. We have 9, right? We have 5, and we have negative 1, right? We know with negative 1, I can't write here. Why can't I write here? At negative 1. Okay, so what we can do is we can do a little analysis. Wow. Okay. So what's going on? We can see what's going on to either side of x equals 9. So take a value and plug it into the function. All right? So we can take values here and plug them in. So what's a good value next to 9? Well, we know that 8 is a good value, right? You can take a value 8, x equals 8. And what's another value to the right of 9? Well, x equals 10. And we can take these values and plug it into the function and see what the sign is, right? Is it going up? Is it going down? What's going on? So if we take 8 and plug it in, I'm not even going to calculate the answer. I'm just going to calculate whether it's positive or negative. So 8 plus 5, that's 3, right? 8 plus 1 is 9. 8 minus 9 is negative 1. Oh, great. So I can't write up here. So it's going to be 3, 9. Okay. And then if I put 8 and 8 in here, that's going to be negative 1 and negative 1. Well, this answer comes out to be positive 27. It's positive 27. So on this side, it's positive. The y value is positive. And if I do that on the other side here, I can just do a quick look. 10 minus 5, that's 5, correct? 10 plus 1 is 11. 10 minus 9 is 1 and 1, correct? So 5 times 11 over 1 and 1 is 55. That's also plus. So both sides are positive. That's why both sides are going to positive infinity. which is what we picked initially, right? So that's how we could do it.